All right, good morning or good afternoon. We are going to look at the last transformation. I know some of you that's going to be a bummage because you really like it, but some of it will also be good. So, a dilation is a transformation that produces an image that is similar to the original but smaller or larger. Smaller or larger. It's similar, but it's smaller or it's larger. A dilation is proportional. Proportional, and you are never going to be able to fit it. If you did, that's awesome. I cannot. Okay? Proportions are what we did last year when we did what was called the butterfly method. And I know my students definitely will remember that. But it was the two fractions that equaled each other, and then you had to multiply diagonally and find the missing number. Okay? So the last part I'm not really worried about. Now, if you look, it says scale factor is image length over pre-image length. So that's a lot of fancy talk for just saying that it's the new over the old. So all that y'all have to understand is which one is the new and which one's the old. Okay? Remember, the new is going to be a letter with that apostrophe. And an old will be just a plain old letter. All right? Now, if the scale factor is greater than 1, so if I take 2 and I multiply it by 6, is the number going to be bigger or is the number going to be smaller? The number is going to be bigger. So this would be larger or bigger, right? Whereas if I multiply it by a factor that is between 0 and 1, so if I take 6, the same number, and I multiply it by 1/2, is that going to become a bigger number or a smaller number? Smaller. Okay? So it says triangle ABC is dilated by a scale factor of, we don't know. That's what we have to figure out. So when you look at this is plane A, plane B, plane C. This is A prime, B prime, C prime. See how it has that little apostrophe? So did the triangle get bigger or did the triangle get smaller? It got bigger. So that means it's going to be a number greater than 1. Okay? So I'm going from negative 5, to negative 10. I'm going from 3 to 6. So I'm just like our welcome work, right? I'm taking a number that's negative 5, and I'm timesing it by something to get to negative 10. Or another one, I'm taking 3, and I'm multiplying it by a number to get me 6. Both of these numbers are the exact same. So the nice thing is once you figure it out, you got it. So what is that number? 2. So this is going to be 2. So it's dilated by a scale factor of 2. That means you multiplied both numbers by 2. And then this down here is just kind of the notation, kind of like how we've looked at the translation notation and stuff like that. So this is just x comma y, that's what you're starting with. And then you're multiplying the x by 2 and the y by 2. If you notice in A to A prime, B to B prime, C to C prime, they're all multiplied by 2. Okay? Now we're going to do the same thing. What do you think about this one? Does a triangle get bigger or does a triangle get smaller? It gets smaller. So when the triangle is getting smaller, it's going to be a fraction. It's going to be something smaller. So it's probably a little bit harder let's put decimals in these. It's probably harder to work with these fractions. I'm sorry, these decimals. So let's look at the other ones. I'm doing 4 times some number, and I'm getting 2. I'm doing -2 times some number and getting -1. So what is happening? What is happening? Well, I am going down by 1/2. So our scale factor is 1/2. We're multiplying both the x and the y by 1/2, which means I'm taking x, comma y, and I'm multiplying both by 1/2. Okay? If you are the person that, again, numbers aren't your forte, these formulas confuse you, another strategy, let me zoom this in just a little bit for you, is a little bit difficult on these. Never mind. I can't do that strategy with these. Sorry. You're going to have to learn it this way for right now. Okay? All right. So let's look at this second page. Let's look at the second page.